Hello, my name is Walter Unglaub, and this is What is the change in the atomic radius of an atom when it becomes a positive ion? We can start by considering hydrogen, which is a composite particle comprised of a single proton in its nucleus and a single electron that orbits the nucleus. And this is for neutral hydrogen. So if we consider the average distance between the nucleus and the electron, we can actually use Bohr's model and define it as the Bohr radius, A0. And this is defined in terms of a myriad of fundamental constants in the universe. The Bohr radius is equal to 4 pi epsilon naught, which is the permittivity of free space, times the reduced Planck constant, h bar squared, divided by the mass of the electron orbiting the nucleus and the charge squared of that electron. This can be reformulated in terms of a couple other fundamental constants, and it's equal to the reduced Planck constant divided by the mass of the electron, also divided by the speed of light, and this Greek letter alpha denoting the fine structure constant, which is very important for atomic physics. And if you plug in the values, the experimental values of all of these fundamental constants, you get an average radius, a Bohr radius, of approximately 0.529 angstroms, where an angstrom is defined as 1 times 10 to the minus 10 meters. Therefore, we have the Bohr radius is approximately equal to 5.29 times 10 to the minus 11 meters. Now, if we consider the process of ionization, that means this electron gets stripped off because its energy is higher than the potential well for this bound state of the atom. Then, of course, we're just left with one proton and one electron. And there is no more atom any longer. The positive ion is just a proton in the case of hydrogen. So, of course, the radius just decreases dramatically. If we consider elements other than hydrogen, so elements that are higher up on the periodic table, such as helium, we have a nucleus of 2 neutrons and 2 protons. And for electrically neutral helium, we have 2 orbiting electrons. If we excite the atom to a high enough energy such that 1 electron is stripped away, then we'll see that there are a couple of factors that will determine a new size. One of those factors is the mere fact that this other electron has been stripped off. That means there will be no electrical repulsion between multiple electrons, because in this case there's just a single electron. So in addition to that, we have a strong electromagnetic attraction between the 2 protons and the electron, which means that the average size or average radius of the atom will actually decrease due to these aforementioned reasons. And we can't properly use Bohr's model because it only accurately describes the physics of the hydrogen atom. But we can determine these trends from experimentally studying the various elements in the periodic table. And we see that, in general, the size of an atom will decrease as we ionize said atom. My name is Walter Unglaub, and this is What is the change in the atomic radius of an atom when it becomes a positive ion?